All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to have x plus 7 squared. If you want to write it as x plus 7 times x plus 7, you can. Either one of them is fine with me. For the math knowledge question, you have to factor it like that. And then x plus 3 equals 0, and x minus 2 equals 0. So that means x equals -3 and +2. And it says, what is the sum of the two solutions? So what is -3 plus 2? They add up to -1. So that's your answer for it. We're looking at lesson 21 today. We're going to look at translations of functions and then graphs of rational functions, part 1. Hopefully, the translations of functions is a pre-cal or maybe even geometry or algebra 2 review. You're just translating a function on a graph. And then the graphs of rational functions, you may have covered a little bit in pre-cal last year, but I'm not sure if you covered much of it. All right, so you hopefully have graphed y equals the square root of x. If you haven't, you can graph it pretty easily just using a chart. You can plug in 0 for x. Square root of 0 is 0. If you plug in 1, the square root of 1 is 1. The next number that we know the square root of it would be 4, and the square root of it is 2. And so you would have 0, 0, 1, 1, and then 4, 2. And then it would just keep going up. If you made it at the square root of x plus 2, your graph would get shifted up by 2. So this whole little graph here just goes up 2. That's how a number out behind your radical would change your graph. So if you did the square root of x minus 2, then it would shift it down by 2. And so instead of starting at the origin, we would just go down by 2. Okay. We can also change what is inside of the radical. So if we made it the square root of x plus 2, you would maybe possibly think that it would shift it to the right because it's a positive 2, but it actually shifts it the other direction by 2. So it gets shifted to the left by 2. So whatever is on the inside, it does the opposite of what you think, or of the opposite of that sign anyway. And so if you had the square root of x minus 2, that's going to shift it to the right by 2. So hopefully you've kind of dealt with that before in a previous math class. So we want to graph the function y equals the absolute value of x. So absolute values are your v's. So the absolute value of 0 is 0. The absolute value of 1 would be 1. And that should be a straight line. It's not exactly straight, but you should get the idea of it. Okay, so that would be the absolute value of x. Then change the equation to shift the graph 3 units to the left and 2 units down. So we want to make our new equation. If it's changing it to the left or right, it's going to be inside of the absolute value. So it says 3 units to the left. So if it went to the left, we're going to have to, that wouldn't be a negative, that would become a plus 3. And then if it shifted it down, that goes on the outside. And so that's just, if it's up, it's positive. If it's down, it's negative. So down 2 would be minus 2. And then you graph the new function. Well, instead of starting at the origin, you're going to go 3 to the left and down by 2. And then you're going to graph it from there. And it's just going to make a little V. And so there would be your graph of your new function. So that's how you can do a translation of a function. We're going to graph the function 1/2 x squared. So that's a parabola, but if you're not exactly sure where your points go, then you can just plug in numbers. So if we plug in 0, you're going to get 0. If you plug in 1, you're going to get a fraction. So I don't want to do that one. If you plug in 2, 2 squared is 4. Half of 4 is 2. So you'll get 2, 2. If you plug in 3, you'll get a fraction. If you plug in 4, 4 squared is 16. Half of that is 8. And so you'll have those points. And then on the other side, you'll have negative 2, 2, and negative 4, 8. And so there's my parabola. Then we want to change the equation to shift the curve 3 units to the right and up 2. So again, a left to right change goes inside with the x. So instead of it just being x squared, it's going to be x plus or minus a number. So we're going to the right by 3, so that's going to be minus 3. And we're going up by 2, so plus 2. So again, we're just going to shift our starting point. Instead of starting at the origin, we're going to go to the right 3 and up 2. And then you can plug in numbers here, or you can kind of do what I'm about to do. From the origin, or from where we started, we went left and right 2 and up 2. So I'm going to go right 2 and up 2, and left 2 and up 2. And then from that point, or from the starting point, either one, we went over 4 and up 8. So depending on where you started, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. You can start from here and then just go over 2 and up 6, or you can start from here and go over 4 and up 8 instead of having to plug them back in. Or you can plug them in if you would like to. So that would be my new graph. Same shape, it's just pushed a little bit around on the graph. Okay, so now we want to graph the function 1/2 x. So 1/2 x, the y-intercept is 0 and the slope is 1/2. And so this is what your line is going to look like. Okay, and then we want to change the equation to shift the curve 2 units to the left and 1 unit down. So y equals 1/2. I shift 2 to the left, it's going to go with the x, and it's going to be plus 2. And then we do down by 1. Okay? So if you graph it, instead of starting at the origin, we're going to go to the left 2 and down 1. But then we're going to do a slope of 1/2. And we're back at the origin. So what do you notice about the line? Hopefully you're noticing that it's the exact same thing. And the reason is because this number and this number is basically just the slope. We went down 1 and left 2, which was what our slope was. Up 1 to the right 2, or down 1 to the left 2. So if you distribute, you should get y equals 1/2 x plus 1 minus 1. So y equals 1/2 x. And so you actually end up with the same graph. So it is possible when you're doing a line to end up with a different line or the same line, depending on what the shift is. Okay, so now we're going to graph y equals the absolute value of 4 sine of x. So the first thing you need to do is to graph y equals the absolute value of 4 sine of x. So if it's sine, it would normally be going through the origin. But since it's the absolute value, it's going to do this, because it's going to have to all be positive. Okay? And this is negative 2 pi, negative pi, pi, and 2 pi. So you don't use these parts down here, just the red part. And up here would be a 4, because our amplitude is a 4. Okay? So we want to change the equation to shift it down by 2 and to the right by pi over 2. So if it's going to the left or right, it's in with the x. So x, if it's going to the right, it's going to be a minus pi over 2, and then we're going down by 2. So right now, it's not in the form of what you think of for a sinusoid equation probably, but if I put the negative 2 in front, it might look a little bit more like what you're thinking of for a sinusoid, where you're going to use half pi. So if we graph it, you're going to have a center line of negative 2. So instead of starting at 0, it's going to start at negative 2 here. And then it's still going to go up 4, so it's going to go up to positive 2 instead of 4. So it's going to do it the same thing. Make your little humps. And so that would be if it were just negative 2 plus 4 sine of x. But what happened here? It gets shifted to the right by pi over 2. And so our graph shifted over by pi over 2. And so now, instead of this being negative 2 pi, it's going to be negative 3 pi over 2. Instead of this being negative pi, it's going to be negative pi over 2. This is going to become pi over 2. And this is going to be 3 pi over 2. And you can keep going from there. So that would be your answer for the equation and for the graph. Okay. Now they give us a graphing calculator picture, and they want us to determine which is which function. So I'm going to color them in green and red and blue. So I'm going to make this bottom one green, next one red, and then the next, just so that it's a little bit easier to refer to. Okay, so now if you look at f of x, g of x, and h of x, they all start with x cubed minus 3x squared plus 2x, and then we have a plus 6 and a minus 3 on 2 of them. So which one is going to be f of x? Hopefully the f of x, you are determining that it is the red one. And then which one would be this blue one? Well, which one got shifted up by 6? The one that says plus 6. So g of x is going to be the blue one. It's going to be on top. And which one would be the green one? Well, the one that got shifted down by 3. That's going to be h of x. Okay? And so that's how that would work. You're just shifting the graph either up or down, depending on what the number is. Okay? So now we're going to graph y equals 1 over x. So x cannot equal 0 here. So we're going to have an asymptote at 0, which is where the y-axis is. And you can plug in numbers. 1 over 1 is 1. 1 over 2 is a half. 1 over 3 is a third. You can plug in numbers, but it's never going to actually equal 0. It's always just going to be approaching the x-axis. And then as you plug in fractions, it's just going to be approaching the y-axis. And the same thing with the negative numbers. So that's not a great but it should never cross the x or y axis. So that would be the graph of 1 over x. You definitely want to become familiar with that one. That's something that you'll graph kind of. Okay, so now this one is changed just a little bit. it is 1 over x, but what happened to it? We have x minus 3. So what happened to this part? Which way did it get shifted? Since it's in with the x, it's the opposite of what the sign is. So it went to the right. 3, and then this 2, it went up by 2. So it's the same graph of 1 over x, but now instead of having the origin here, it's going to be at 3 and 2. And so we're going to have an asymptote here at 3 because it can't ever equal 3. And then there is technically a horizontal asymptote. We didn't draw it on the last one, but on this one I'm going to draw it so that I know what line to approach. And so it's going to do like that and like that. And so that would be the graph of that function. Okay? So that's how you can use the parent function of 1 over x to help you graph this without having to plug in a bunch of numbers. It just makes it a little bit quicker for you whenever you go to graph it. Okay? So now we're going to graph y equals negative 1 over x. So that is going to be the mirror image almost of what we just graphed. You're going to reflect it across the the x-axis basically. So we put our asymptote on the y-axis, and again, if you want to put one on the x-axis, you can, but you don't have to. So negative x is going to be in the second and fourth quadrants. I didn't do a great job of graphing that one. So there's going to be that graph. For this one, the way that it is written is a little bit strange because it's got the x second. So we need to make it negative x plus 3 and then factor out that negative. So that makes it 1 over negative x minus 3. Okay, so we're going to have an asymptote at 3 because it gets shifted to the right by 3. And then it's the graph of this one that we just did, negative 1 over x, shifted over by 3. So it's going to look like this. Okay, so that's for that one. Now for 1 over x squared, it is going to be in the first quadrant because it's a 1 over x, but it's just squared, so the numbers, and it should be crossing at 1, 1. The numbers are still going to be positive. And then whenever you plug in negative x values over here, you're going to get positive y values, so it's going to look like this. And there is a vertical asymptote on your y. So it's going to look like a volcano. So that's how you can graph your 1 over x. You definitely want to be familiar with the graph of 1 over x. Okay, so you'll use the graphs of those on your homework for number 14 and 15 to find the limits of them. So you want to graph it first and then look at the graph to be able to find your limit. And that's what they're starting with for this lesson. On your homework, you do get to omit number 21 because it's a develop an identity that we're not developing this year. So make sure you do the other 24 tonight so that we can go over any questions you have tomorrow.